So let's start with this one. What is the domain of a logarithmic function? So tricky. So it's a log function. And it's just a plane, right? It's just base 4, log base 4. But honestly, it's just a log function. Now, do I have an asymptote? Yes. Where's the asymptote? X equals 0. So there's no x values left of 0. It's 0 onward. Awesome. Oops. So this is correct. Cool. So most people understand domain of a log function. I probably should have did question 3 first. All right. Which function is a transformation of 2 to the x 3 units to the left? So if I wanted to go 3 units to the left, do I, multiply? Oh my gosh, I even changed the base. This is a base of 3. That's not even a transformation. That's not even close. I just put 3 and 2 in there randomly. Second thing. Okay, so what does this 3 in front do? What does this 3 times 2x to the x? It makes it, so it used to kind of look like a semi-u. It's now a, shifts everything up by a factor of 3. All of my y values are now, shot up. It stretches it vertically. It's a vertical dilation, makes it bigger. Exactly. So now the question is, we are tossed up between the first two options. Do I have a plus or do I have a minus? If I'm trying to go to the left, you would think it's a minus. Just kidding. Anytime it's horizontal, it's always opposite the way you think, so it's going to be plus. So this is solid. You guys didn't fall for my shenanigan trickery. It's just knowing if you have a horizontal, left is negative, but that means it's going to be plus because whenever you have a horizontal translation, it's opposite the way you think. And then lastly,
but if it was plus 2,
if I wanted it, if I have this one right here that's still in gray, the 2 to the x minus 3, that's a shift to the right by 3. Yeah. All right, lastly, this is an exponential function. 8 to the negative x is literally 1/8 to the x power. Is it exponential growth or decay? Decay, because it's between 0 and 1, right? 8 to the negative x is literally just 1/8 to the x. Doesn't matter. All exponential functions have a domain of all real numbers. All exponential functions have a domain of all real numbers. Perfect. Save to your portfolio. Cool. Okay, so hopefully that's a little bit of review because there are going to be 2 questions. One of them I'm going to ask you about transformation. The other I'm going to ask you about domain. You have a 50-50 shot. Either I'll give you a log question or an exponential question for the domain. Okay, cool. So we don't have too many notes left. Literally 2 problems. And once we're done with that, we'll go over the practice quiz, and I'll set you free to work on Alex or review or do whatever you do.
If it was minus 6, that's not e x. If it was e the x minus 6, would it go down 6?
I'm gonna lie, I'm doing something just long. Okay. Andy, what was your question? It was.
Okay, I'll ask you again.
Okay. Yeah. Okay, so let's go. So, throwback. Method 1 that we learned last time. We rewrite our log in exponential form. We plug in the x and then solve what the y would be. Guess what method 2 is? Plug in the y and then see what x is. Okay. Why do we call really 2 different methods? Whatever. Showing you how to do it 2 different ways. Okay, so method 2. Let's go ahead and let's rewrite in terms of an exponential function. So throw back, right? So we take whatever the base was, curly Q to whatever the equal is, and then around to what was before the equal sign. It's like a little curly Q, circle, I don't know, spiral. Yeah, it's like a ham. It's a spiral. Cool. So I have 1/3 to the y is equal to x. Okay, not too bad so far, right? Just converting to an exponential and log form. Now the asymptote. So remember, log functions are the inverse of exponential. Exponentials have a y equals 0 asymptote. So an inverse switches x and y, so now I have a x equals 0, right? Asymptote. Okay. We have an asymptote at the y-axis, because this is just a plain log function. I haven't started with transformations yet. Yes?
So on the test,
Quiz?
Will there be any problems we have to move?
There will be, the graphing problem is on the non-calculator portion.
Like, how do we know how to move the y asymptote?
If it's inside, if it's log base 1/3 of x plus 2, if it's in with the x, it's horizontal. This is what I'm talking about. If it's log base 1/3 of x plus 2, shift left to the 2 because it's in with the x, right?
So the asymptote is -2.
Yeah. Horizontally, it shifts over as well.
What if there was like a
Versus if I have log base 1/3 of x and then plus 2, this shifts it up. Everything up by 2.
what would the asymptote?
Here, for the second one, it'd still be at x equals 0. All we do with the whole graph, because the graph, okay. Like, kind of like that, right? It's a log. So what you do is you just shift it up or down. You're not moving it horizontal.
But if it wasn't a log problem, then it would be y equals 2.
What?
Like if it wasn't a
If it was exponential.
Yeah.
Yeah, because that's what we've done. So that's what we've already done. Okay, I'm pretty sure the next problem is. Yep, we're doing some shifting next problem. Okay, so we're going to use the equation we just wrote right here. Bring it down, and I'm going to plug in y value. So I have 1/3 to the -2. Okay, get rid of a negative in the exponent by flipping the fraction. So I have 3 squared, which is just going to be 9. I like this method easier because you're just plugging in and then finding what will be. I'm picking nice numbers for my exponent that I'm plugging into. So, all right, let's try it again. So I have 1/3 to the -1. So that's just going to be 3 over 1 to the first, which is 3. Go ahead, fill out the rest of this table. I know you can do it. The tricky part is if you have 1/3 squared, it's literally going to be 1/3 times 1/3. Or you could say 1 squared over 3 squared. So that's just 1/9. Alright, so at an x value of 9, my y is -2. So 9, comma -2. 3, comma -1, 1, comma 0, 1/3, comma 1, 1/9. So I'm getting really, really close. You can see the curve. You can see the curve coming down. So this is logarithmic decay. It's a log function, and it's decaying, so it's getting smaller. Yes. You can ask me that later. What? Why don't you ask me in like 10 minutes when I go over a quiz? Cool. I'm pretty sure I didn't grow horns overnight, but I gotta make sure I didn't. I gotta check. Yep. Because I did. I sat here doing everything until like 8 o'clock last night. I made quizzes. I have a practice test for you guys. Because the day you take a quiz, guess what? I give you the practice test for the next assessment. That way you can see how I will ask things on the stuff.
Is vectors going to be next unit?
No. Vectors are in March. So it's after sophomores get back. So it has explanations and also you can come into bonus.
Okay.
Yeah. Okay, so we have it graphed. Notice we have a vertical asymptote. This is logarithmic decay. Gets smaller. Cool. The previous one, if you look at your previous page, I think it was logarithmic growth. I don't remember. Let's look. Yep, growth, because the base is larger than 1. All right, domain. Let's start with Shane. What's the domain of this function?
Domain is 0, comma.
Beautiful, beautiful. 0, comma, infinity, right? It's not defined for 0 to our asymptote, but everything greater than 0 is included. All right, Danny, what about the range? The y values. Exactly. It's all real numbers for our range. Because as we go left towards 0, it goes up to positive infinity. And as we go to the right, it just keeps going down and down and down. I did not draw that very nicely, but it should just keep going down, something like that, going down, down, down. Okay. This should say x-intercept. Why did I make an x-intercept, not y? Because there's no y-intercept. That was great. It's a chorus. What is the x-intercept, Hannah?
1,
Yeah, 1, comma 0, exactly there. All right, end behavior. So, shoot. This should instead say 0 from the positive side. So left end. Okay, as we approach 0 from the right side, so we're getting closer and closer to 0 from the right side. Okay, so what this means is we're coming from this side, we're getting closer and closer to our 0 value. What is y approaching, Ava?
Infinity.
Exactly, it's going up to positive infinity. And lastly, the right end limit, Ellie, what is, as x goes to positive infinity, what's happening with my y? Negative infinity, wonderful. Ooh, tricky. Do you want to do continuity? I'm going to give you a free card. Do you want to do it or no? All right, cool. Because you're gone. You're gone. That was so unfair of me. All right, Andrew. Benson. Hello. Continuous. Where am I continuous? Not for negative numbers.
Is it negative? Oh, I mean 0 to positive.
0 to positive infinity. Yep, 0 to positive infinity. More or less your x. A lot of times continuity is going to be very, very similar to your domain. You just have to make sure you don't have points of discontinuity. Okay. Last problem. Ooh, so this one is, I'm just trying to throw a trick play at you. All right, trick. So this isn't just ln of x, right? Because ln of x is the same thing as saying log base e of x. Ooh, what's happening? How is this different than the normal ln of x? Shifted to the right by 6. How do you know it's to the right? It's a negative. Opposite direction. Okay, I know I'm playing dumb right now, but I want you guys to have this ingrained in your memory. Okay, so left by right by 6. Okay, so I want to rewrite this. Now the first thing I need to do is, I'm going to rewrite this as y equals ln of x minus 6. Now I need to move everything to the other side. I want to rewrite it. Let me, instead of saying ln, let me say log base e. So I have e to the y is equal to x minus 6. I have e to the y is equal to x minus 6. Now, if this 6 was on the outside, you'd have to move it to the other side before you do the whole.
So it'd be e to the y plus.
So if this was instead, I hope this doesn't confuse you. I just want to be clear. If this was f of x, it was equal to ln of x plus 6, right? There's no parentheses, it's outside. You'd have to move the 6 over, so y minus 6 is equal to log base e of the x. So then you would have e to the y minus 6 is equal to x. Yeah. It's just order of operations. You got to get the logarithmic part by itself first. I got to look how I did on the quiz.
Do you want us to write?
What questions? I'm not done with this one yet. Okay. So over here, I want to get x by itself. So I have x is equal to e to the y plus 6. Okay, was that your question? No. Okay. Cool. So we rewrote it in terms of an exponential, right? It's x is equal to blah, blah, blah. Where's our asymptote? Normally, for logs, we have a vertical asymptote at x equals 0. But everything is being shifted right by 6, including the asymptote. So our asymptote used to be at x equals 0. But now we shift it over by 6, so now it's at x equals 6.
If it was outside the parentheses,
The asymptote would not move. It's just the whole graph would be shifted up. That'd be it. So I personally like just plugging in integer values for my exponent. So I'm going to choose like -2, -1, 0, 1, and 2. They're the easiest exponents to work with. So then I would have e to the -2 plus 6. Like, I'm not expecting you to know what this is equal to. This would have to be a calculator question. E to -1 plus 6. Oh my gosh, this is, once again, have to be a calculator question. But you could do the rest, right? You could do at least e to the 0. E to the 0 is 1. 1 plus 6 is 7. E to the first plus 6. E squared plus 6. Does everyone know where the e exponential button is to like write this out and figure it out? Yeah? Okay. Just going to show you briefly. I didn't sense enough confidence, so just gonna make sure we know where it is. Okay, so if I want to figure out what it is, there's this little e to the x button. I'm gonna do e squared, and then shift over and say plus 6. Cool. So that's how I found the numbers. All right, it's a little e to the x right there. Similarly, if I was trying to find, well, I mean, that's it. I think I showed you the rest of it, so. So make sure you guys know how to use your calculator for the quiz. Okay, so I have some points. You gotta roughly sketch where they are. At x equals 6.14, so it's very, very right after 6. I go down to -2, so it's about right here. Then about 6.5-ish, I'm at -1. You just have to like eyeball to the best of your abilities. And then at exactly 7, 0, perfect, that's a great dot. 8.72, it's about 3/4 the way between 8 and 9. I go up to 1. So it looks something like that. And since my base is larger than 1, right, e is 2.7, we have exponential growth. So I get really, really close, but I don't cross the asymptote. So important, you have to draw your asymptote, and you must draw your log function. I think I left off on Andrew. Do we need more time for this? Mika is going to give us the domain of this function. What's the domain here?
is it 6 colon?
Exactly. I start at 6 and I go to infinity. I don't include 6 though. Andy, what's the range? Yeah, all real numbers, -infinity to infinity. The x-intercept, Maya? Yep. And this should say 0 from the right side. Nope, just kidding. I wanted it to say 6 from the right side. Aha! Daniel.
So, as x approaches 6,
It's from the right side, yeah. As we come from the right side, as I approach 6, what's happening?
negative infinity.
Exactly, we're going to -infinity. Andrew G, what about the right limit as x goes, Positive infinity. And then Jake. Do people ever make the joke, Jake from State Farm? Okay. Where am I continuous?
From 6 to 10.
Beautiful. Awesome. Cool. So we're gonna go over the practice quiz. I'm sorry, that was probably appropriate. I'm sorry about talking about Jake from State Farm. Yeah. Okay. We'll go over the practice quiz, yes? Yes. Let's do this. So, about the lesson?
Yeah.
Yes.
So for the asymptote, if the thing is inside, it's like x minus 6. Do you know that it's 6 because it's minus 6, and then if it said like x plus 2, it would be minus 2?
If it said x plus 2, it would be minus 2. Yeah.
And if it says x minus 6?
Yeah, it's because it's the same rules as like how if you have like x plus 2 squared minus 3, right? It's the same translation rules. If it's inside with the x, it's horizontal and it's opposite way. If it's outside, it's vertical and it's the same way it
And
says.
the inside is where it's the asymptote.
Yeah, for log functions. So, like if I had e to the x plus 2 minus 3, like this would be a shift left 2 and down 3, versus if I had
What would the asymptote?
log, what?
What would the asymptote be?
The asymptote here would be at y equals negative 3
Would the asymptote be y?
for exponential. If I had log of x plus 2 minus 3, so although we're going down by 3 and left by 2, our asymptote would be at x equals negative 2. Because notice, this is a vertical asymptote versus this is a horizontal asymptote. So I want you to see, like, inside is horizontal. Outside is vertical.
They would also, okay.
Yeah. Vertical shift versus horizontal shift.
So the vertical asymptote is negative 2.
Because logs have a vertical shift, our asymptote, because logs have a vertical asymptote, our vertical asymptote will be shifted left and right. Because exponentials have a horizontal asymptote, it will be shifted up and down.
So for that one, it's going to be on negative 2, but then just the graph moves down 3.
Yeah.
For the second one.
For this guy, right? The log, yeah. Hi. Hello. What?
I just want to know, so on the test, are we going to do like a...
Is this a practice?
Yeah.
Okay, I'm going over it now.
Okay.
That's the next thing we're doing.
I wasn't sure.
Okay, I just want to, like, before we moved on, get all those questions out. All right, so everyone has a practice quiz. Chapter 3. Practice quiz. Okay. So, what is the domain of this function? So directions, read each question carefully, write the answer, letter choice correct on the line. Okay. So what is let's do domain and range of this function. So first, is this exponential or log? Exponential. Growth or decay? Decay. So we roughly know what it looks like, right? Decay looks like that. Plus 3. What does this plus 3 do? Up by 3. Okay. So we have an idea of what it looks like. It's exponential decay, but shifted up by 3. Here you go. You already know what the graph looks like. So, domain and the range. I think I left off with Ethan. What's the domain? Perfect. Because it is an exponential function, it's defined for all real numbers.
Is that for all of the exponential?
For exponential, it's always all real numbers for domain. Try tricking you with, x 8 to the negative x. Like, oh, just kidding. That's literally 1/8 to the x. Range. Bradley, what's the range here?
3 to infinity.
Yeah, exactly. 3 to infinity. Because roughly, okay, so exponential functions, if it's decay looks like this, but since we're shifting up by 3, it would roughly look like that. Because I have to go up to 3. Right, shifting everything up by 3. Okay, questions on that one? Cool. How about this next one? So 6, which function is a transformation of f of x equals e to the x, reflected over the x-axis and shifted 6 units down. So we're going down by 6, and reflected means negative e to the x.
How do you know, in this case, that it's minus 6? How do you know
6 units down. Down is vertical, so I know I'm going down 6.
isn't it the opposite? So if you
No, horizontal is opposite.
What would it say if it wasn't negative e to the x?
What?
What would it say instead of reflected if it wasn't?
Oh, I would just say, shifted 6 units down. Reflected means you have a negative coefficient in front of e to the x. Because it flips it. So it's just going to be this guy.
What could be other, like, for number, or for the letter A, and then minus x plus 6, like, how would it be minus x? Like, what would be said?
So, what?
Like, what would be said? Like, how would you write that to get that?
Reflected across the y-axis and shifted right by 6.
It'd be reflect.
Well, okay, so if you rewrote this, you could literally write this as e to the negative of x minus 6. So this would be 1 over e to the x minus 6. So then it would be decay, and it'd be moving, then it'd be moving to the right by 6, yeah. Okay, try out number 3. Describe the end behavior. Sorry, do we have questions over this one? We went over, type already some of these problems, beginning with our quick poll questions. Give you 3 more questions already. Describe the end behavior of log base 1/5 of x as x approaches 0 from the right side. So is this growth or decay? So that's really the question. Is this logarithmic growth or logarithmic decay? Because logarithmic growth looks like this, right? Because it's getting bigger. It's growing, and as we approach 0 from the positive side, it's going down to negative infinity. Versus logarithmic decay looks like that because it's getting smaller. So as you approach 0, it'd be going to positive infinity. So you really have a 50-50 shot. So remember, as we approach 0 from the right side, you have to have this. You have to have the 0 from the right side. And are we going bigger or smaller? Am I going to infinity or negative infinity? Well, let's see, our base is 1/5. Our base is 1/5, so it's logarithmic decay. So it's going to be going positive, so let's see. Because it is 1/5, I know logarithmic decay. So as I get closer to 0, our y value is going up to infinity.
It doesn't say approaching. Oh, wait, never mind.
Yep, 0 from the right side. Give you guys a moment to catch up, think of questions you have for the first 3 before I go over 4 and 5.
Could I ask,
Give me a moment to catch up so I can do something myself.
okay.
4. Okay. What's your question?
For the formulas, E, right? Like, instead of K, we put rate. Is it wrong?
So I'm going to go over this now. So, what are the 2 formulas used to find investment that earns compound interest? So, the difference is growth or decay versus investment. Money versus things that are increasing or decreasing. So, money is when you have a PERT. Because literally that's, guess what? I just told you, 4 and 5, I'm going to ask you. You have to know the equations, right? You have to know them. I'm not going to give them to you. But I'm going to choose very specifically. There's 2 formulas to find investment that earns compound interest. So investment interest are the ones where you have principal. So those are the ones with P. So you can have A per A equals P times e to the RT. Now, this is going to be exponential, right? Continuous, if I'm asking you for words, not exponential, but it has e because it's the continuous growth, continuously compounding. Versus A equals P times, no, it doesn't. If you just put parentheses around it like that. Like that? Oh, well, it's messy, but you do you. As long as I can read it. I tried to be able to translate hieroglyphics, but I'm not the best, so just make it readable. A equals P times 1 plus R over N to the NT. So these are the two ways to write it. One of them is discrete, the other is continuous. Do you know the difference between discrete and continuous? So if I go to the store, which I do every Saturday after my training, I go and buy bananas. If I go up to the cashier and I say, I want 1.47 bananas, she's going to be like, what the hell? No, discrete. I only can take multiples of bananas. 1 banana, 2, 3, 4, 5. Right? They don't let me buy half a banana. That is discrete. You have to have a certain amount, right? Discrete. Certain increments. Versus continuous. If you go to these, like these fancy spice shops, you know, in Calabasas, super bougie, but it's amazing because you can get like really fresh herbs, right? Really good herbs. They will charge you for every 1/1,000,000th of a gram that you buy. That is continuous. They measure that out and they charge me for every single grain. That's continuous. Every little incremental amount, right? Continuously compounding is all of the spice I buy because I have to pay for every single gram. Versus my bananas are discrete. Okay, I'm compounding once a month. I only can buy 5 bananas, not half a banana. Does that make more sense? You use with continuously, you use the one with E. Discrete, quarterly, monthly, whatever. You use the second one. Cool. And this is for money. This is for interest. Okay. Now, versus if a population is growing or decaying at an exponential rate. These always have n because it's the number of like living things. So there's two equations. One is just like a per, but it just has different variables. Because n is the number of living things at the end. N to the 0, right? N naught, n initial. That's how much we start out with. K is the rate, but it's not just rate because it can be positive or negative. Normally for money, it's only a positive. It's always a positive rate. You know, maybe it's you know, losing your money, right? You're leaking money, but it's still a positive interest rate. But you can have something that's decaying, getting smaller. And then similarly, our second equation is n equals n naught, 1 plus r to the t. Have you guys learned all 4 of these before this class? Maybe?
Wait, so if I put...
I know for sure you guys have learned like this one before. And this is from science.
If I mix up R and A, does it matter?
Like if you put r here instead,
Yeah.
that would be okay. Because technically it's a rate because I put r.
Wait, what is K? What does that stand for?
K is your rate according to the book. If you put r, that would be fine, but that's really the only thing.
And I messed it.
This is continuously growing versus this is like, you know, your annual, drops per year, right? Annual is the second one because it's how much per year. It's not just like consistently decaying, consistently losing. Like, you know, we all of a sudden have half a person. Like, no, it's either you have one person or none, right? You lose in increments of person. Yeah?
So quarterly would be the second one also.
Quarterly rate. Quarterly is interest, right? If you're collecting interest during quarter, it's the compound interest.
So then that would be the...
Because for growing or decaying, it would only be, really like continuous is like you have uranium that's decaying continuously. It's not going to be like, yes, once a year, let out all of my isotopes. Like, no, it just continually like goes and let's lose. Versus we only take a census, every 10 years? So we could figure out our annual difference, decline in population, yeah?
So how would you get
So I'm trying to like be specific with like the words I'm using. So if it's like people and population, you have to use N, versus if it's money and investment and interest, you have to use the A. Amount of water being used, like you only use the A's if you're talking about money. But my example of discrete versus continuous was like trying to show you when you use one versus the other what it means. But you mostly use the second one Like, oh, what's the, annual decline in population? How much water is the Ogallala Aquifer in the center of America losing water per year, whatever. Like, that's when you use those, because normally you have like a yearly change that people like find. Okay. Let's do the next two. So we get some real shifty shift time. Graph and analyze this function. So let's discuss what's happening here. What is this +1 doing? Who am I on? Rocky? Yeah.
It's shifting it to the left.
Left by 1, and then Sarah, what is this doing right here, the 3?
Up by 3.
Up by 3. Okay, wonderful. Up by 3. Okay, so what are some like good numbers to plug in? Because we have an exponential form. There's some like nice numbers we could use. Yeah, since we're shifting everything left by 1, normally we would like center around x equals 0. But I want to shift it and center around x equals -1. And so then I'll fill in the numbers that are around it. I want to have the easiest numbers to compute. That would be great. So this is where I'm centered around because I'm shifting left by 1. That's why I put that in the middle. Okay, so let's go through and let's find it. So I have 1/4 to the -3 plus 1 and then plus 3. Whew. 1/4 to the -2 plus 3. Okay, 1/4 to -2 is the same thing as 4/1 squared. 4 squared 16. 16 plus 3 is going to be 19. That's off our graph. Wow, not helpful. Let's try the next one. After we finish the practice test, I'll give you specifics. Oh, wow, we only have like 2 minutes left. How did that happen? Okay, that took a long time, yeah?
For this one, how do you know if you're plugging in the x or the y?
You're plugging in x values.
Right, but for the other one,
Because it's a logarithm. And we had to convert the log into an exponential functions. And we already have an exponential function.
Is the asymptote still 3 or would it be -1?
The asymptote is going to be y equals 3. Because this is an exponential function and I'm moving everything up by 3.
Isn't there also a horizontal?
I'm sorry. This is the horizontal asymptote.
And then isn't there also vertical?
There's not a vertical one. That's only for logs. This is an exponential function.
Okay. Thank you.